All right, so we are going to factor polynomials. They give you this lovely trinomial here. It has an x squared, an x to the first power, and a constant. When you get a trinomial like this and they ask you to factor it, your first inclination should be, ooh, it might be a binomial times a binomial, just like we did up here. When you multiply two binomials together, you get that sort of an answer, an x squared, an x to the first power, and then a constant. However, the first step in factoring, according to the poster on Unit 6, is to look for the GCF first. Now, greatest common factor means it has to be something in common to all three pieces. Are there x's in all three terms? No, so I cannot pull an x out. There's a 1 sitting in front of this x squared. And now I'm going to look at the big numbers, the 1, the 14, and the 40. Well, 2 will go into 14 and 40 evenly, but 2 won't go into 1. And since there's a 1 in front of this one, the only number that will go evenly into all three numbers is a 1. So there is no GCF that I can pull out because pulling out a 1 doesn't do me any good. So no GCF, but you always check that first because tomorrow there will be a GCF to pull out on sometimes. And if you don't pull the GCF out first, it will make it much harder to factor. So always look for a GCF first, greatest common factor. But we already determined there is no greatest common factor. So now I'm thinking, ooh, it could be a binomial times a binomial. Now, there's sometimes you'll get some that are not factorable, and we will get some of those this week where they're not factorable. But for right now, today, I think they're all factorable. So something times something is going to give me x squared. Well, up here, to get x squared, what times what gave you x squared? It's x times x. So I should have an x at the beginning of that one and an x at the beginning of this one. Now, I have a number here and a number here. When I multiply those two numbers together, they have to equal the number on the end, the 40. See up here, the 3 times the 5 gives you the number on the end. Okay, I'm not worried about the middle number right now. I just want the ends, the two ends. So to get the x squared, it's x times x. These two numbers multiplied together have to equal 40. So let's make a list of possible factors of 40. Start with the number 1. 1 times what? 40. 1 times 40 equals 40. Now 2. 2 times what is 20? If you're not sure what 2 times what is 40, take 40, divide it by 2, and it will tell you it's 20. So write down the two numbers that are being multiplied together to give you this. 1 times 40 is 40. 2 times 20 is 40. 3. If you're not sure if 3 times something equals 40, then take 40 divided by 3, see if it goes evenly. If it does, put that number here. Did you try it? Put in 40 divided by 3 in the calculator. Does it go evenly, or does it give you a fraction or a decimal answer? You're right. It gives you a fraction or a decimal answer, so it does not go evenly. So let's try 4 now. 4 times what? If you don't know what the number is, do 40 divided by 4, and it will tell you the answer is 10. So 4 times 10 equals 40. So I'm making a list of numbers here that multiply together to equal 40. These are factors. 1 times 40, 2 times 20. 4 is a factor, 10 is a factor. 5. 5 times what is 40? If you know your multiplication facts, you might say, oh, it's 8. If you don't know it, divide 40 divided by 5 and find out that it's 8. 6. Will 6 go evenly into 40? If you're not sure, do 40 divided by 6. Do you get a fraction or do you get a decimal? Yep, you get if you're in decimal mode, you get a decimal. If you're in fraction mode, you get a fraction. It is not a whole number. Let's try 7. 40 divided by 7. Put it in the calculator. You're right, it does not go evenly again. And now I'm up to the number 8, and 8 I've already used. So when you get to a number you've already used, you can stop. So these are my choices. These two numbers are either 1 and a 40, or 2 and a 20, or 4 and a 10, or 5 and an 8. Rather than having to go through and check each one and see which one works, there's a better way to figure out what the middle number is, or to figure out which pair to use. To figure out which pair to use, you look at the middle number. This is a 14, so I'm going to write it over here, negative 14. I'm going to put a circle around it, box it, something to let you know that's the number we're looking for. So what I'm going to go do now is take these combination of numbers and add them or subtract them and see if I can get a 14. If I add 1 and 40, I get 41, not my number. If I subtract 1 and 40, 40 minus 1 is 39, not my number. So cross that one off. If I add 2 and 20, I get 22, not my number. If I subtract them, 20 minus 2 is 18, not my number. And I'm not worried about the negative sign right now. I'm just looking to see if I can get the number. 4 plus 10, hey, that's a 14. If I subtract them, I get a 6. I'm going to keep this pairing right now. If I add these, because 5 plus 8, don't stop with the first one that works, because you may get two pairs that will work, and then you do have to try both pairs. But 5 plus 8 is 13, not my number, and if I subtract them, I get a 3, so not that one. So 4 and 10 are the two numbers. So I write them down where I can see them. The last thing we have to do is to figure out what the signs are going to be. Now, are we adding to get to 14, or are we subtracting to get to 14? Well, 4 and 10, to get to 14, they have to be added. So as long as you're adding, either they both have to be positive or they both have to be negative. Since my answer is negative, I'm thinking they both need to be negative. So in the calculator, you can put -4 plus -10 and see if you get a -14. Always check this final step before you go on. Otherwise, you'll have everything done right and then make a mistake on the very end and have the wrong signs. If you tried a +4 and a +10, it would tell you +14, which is not what we want. If you make one positive and one negative, again, it won't give you the answer we want. So make sure that you check the signs. -4 plus -10 is -14, so it is -4 and a -10. So I'm going to put -4 in one of the parentheses and -10 in the other one. So if you were to go do the double distribution, you will wind up with this answer up here, x squared minus 14x plus 40. If you wanted to see it just to see why that works, x times x is my x squared. X times 10 is a -10x. -4 times x is a -4x. Negative times negative is a +40. Notice I have my +40s on the end, and I got my x squared on that end. And when I add these two in the middle, these two like terms, -10, -4, does that give me a -14? Whoops, x. I can't write and talk. Yes, that gives me my -14x in the middle, plus the 40 on the end, plus the x squared, so this does work. All right. Now, this one. So same thing again. I always look for a GCF. If there's a 1 in front of this, then there is no GCF because the only number that will go evenly is a 1. But also check the x's. There's only x's in the first two pieces, not in the third piece, so there is no GCF. So I'm hoping it's going to be a binomial times a binomial. So what times what will give me x squared? I need an x and I need an x. There we go. Now, to get the 5, let's make a list of possible factors. 1 times 5. 2, will 2 go evenly into 5? No. Will 3 go evenly into 5? No. Will 4 go evenly into 5? No. And 5 I'm back up here. So 1 times 5 are the only combinations I can have. So I know it's going to be a 1 and a 5. The question is, what are the signs going to be? I want them to get me to a -6. So do I need to add them to get to 6 or subtract them? Well, subtract them would give me a 4, so I'm not looking for the 4. So I'm adding these to get to the 6. So if you're adding, either they're both positive or they're both negative. If you make them both positive, you get a +6. We don't want that. So I'm thinking if I make them both negative, bad guy and 5 more bad guys give me 6 bad guys. So that is correct. -1 minus 5. Here we go. And if you were to multiply doing the double distribution, that's what you would get in the final answer. So x minus 1 times x minus 5. X minus 1 is a factor, and x minus 5 is a factor because things that you multiply together are called factors. The answer is a product. All right, number 3. Now, at any point at this point, you've got this, especially if you did them the week before we left for the snow week, then go ahead and work a few on your own, check the video, and see how you did. At any point, though, before you finalize and take a picture, make sure you check the answers to make sure you got them right, because it's important that you know if you're getting them right, because if you're missing them, you need to know that so you don't keep making mistakes and then get them all wrong on the test. So make sure you pause the video, go work a few, and then check the video, see if you got them right. If you're missing them, watch me work them and see how to do it. All right, so the next one. Look for a GCF first. We're factoring this. And it's a squared term, x to the first, and a number. So I'm thinking binomial times binomial, but check for GCF first. Are there x's in all 3 pieces? No, so I can't pull an x out. Is this starting with a 1? Yes, so 1 is the biggest number that will go evenly into all 3. So no GCF that I need to pull out. So now my next step is to multiply or find the 2 things that multiply together. Will it always be factorable? No, but hopefully today they are. What times what will give me x squared? Well, the first thing has to be an x and an x, because x times x gives me the x squared. Now this number times this number has to equal 35, so let's make a list. 1 times 35 is a possible combination. 2, will 2 go evenly into 35? No, it won't. How about 3? Will 3 go evenly into 35? I sure thought it was going to, but no, it won't. 4, will 4 go evenly? No. 5? Yes, 5 times 7. And 35 divided by 5 is your 7 if you do it that way. 6? Nope, won't go evenly. 7, I've already used. So I only have 2 choices, 1 and 35 or 5 and 7. So look at the middle number. It is a 2. Write it down. It is a +2. If I add these, will I get a 2? No, I get a 36. If I subtract them, I get 34, not my number. If I add them, I get a 12, not my number. But if I subtract them, I get my 2. So I'm thinking I need to subtract them to get there. So if you're going to subtract, that means one number has to be positive and one number has to be negative. I want the answer to be positive, so I want the good guys to win the war. So if that's the case, should I make the bigger number positive? I'm thinking so. So then you check it. Always check it in the calculator. Negative 5 plus 7, do you get a positive 2? If you do, then this is the right signs. If you don't, try switching the signs. So negative 5 plus 7 did work. So this is negative 5, and this one's a positive 7. Now, could I put the positive 7 in this one and the negative 5 in that one? Sure. Order won't matter on multiplication. All right. Again, pause the video and go try one on your own, because at some point you've got to start trying them on your own and then checking after you do them. But make sure you do check your answers after you do some, because you don't want to just work them and think you got it right and then realize you're doing it all wrong. You want to know that before test day. So again, we're factoring. It's a squared term, an x to the first, and then a constant. So I'm thinking binomial times binomial, but check for GCF first. Are there x's in all three pieces? No. Is the first one starting with a 1? Yes, that means 1 is the biggest number that will go evenly into all three. So there is no GCF to pull out. So I'm hoping that they are indeed factorable. What's going to give me an x squared? X and an x. When I multiply x times x, I'll give me the x squared. This number times this number has to equal a 10, so let's make a list of possibilities. I always start with 1. 1 times 10 is 10. 2. 2 times what is 10? 2 times 5. 3. Literally make this list 1, 2, 3, 4, 5, 6, 7, 8 until you get to the number you've already used. 3 will not go evenly into 10. Cross it off. 4. 10 divided by 4 is not an even number either, or not a whole number. 5. We've already used 5, so I'm done. So either it's 1 and 10 or 2 and 5. So either 1 and 10 go there, or it's a 2 and a 5. The middle number is a 9. And it's a positive 9, positive 9. So if I add these, I get 11, but if I subtract them, I do get my 9. If I add these, I get 7, and if I subtract them, I get a 3, so it's not that combination. It's either 1 and 10 are the two numbers that I want to look at. And to get to 9, I need to subtract them. So if you're subtracting, one has to be positive, one has to be negative. The answer is good guys, so who should win the battle? Good guys. So which one should be positive? The bigger number, yes, because I want the good guys to win. Check it in the calculator. Negative 1 plus 10 should give you a positive 9. If it does not, change the signs. But negative 1 and positive 10 do work, so minus 1 and plus 10. There are the two factors. X minus 1 is a factor, and x plus 10 is a factor. All right, number 5. Again, stop your video and go do some on your own, then check. Are there x's in all three pieces? Nope. Is this one starting with a 1? Yes, so there is no GCF. So, but I always check that first, because if there is a GCF, you want to find it first. What times what will give me x squared? X and an x. These two numbers multiplied together have to equal an 8, so let's make a list. 1 times 8, 2 times 4, 3 won't go evenly, and 4 I've already used, so there's only two possibilities, 1 and 8 and 2 and 4. The number is a 9. So if I add these, I get a 9. If I add these, I get an 8, and if I subtract, I get a 4, so this is the one I want, 1 and 8. Now, since we are adding these to get to a 9, either they're both positive or both negative. Since the answer is positive, I'm pretty sure they need to both be positive. And 1 plus 8 is indeed positive 9, so plus 1 plus 8. There we go. All right, so same thing factoring. It's an x squared, x, and a number, so I'm thinking binomial times binomial, but check for GCF first. This has got a 1 in front, so there's not a number that I can pull out besides a 1. And x, x, and no x's, so there is no x to pull out of all three. So hopefully it is factorable into a binomial times a binomial. What times what is x squared? X times x. What number times another number is equal to 20? Well, let's make a list of possibilities. 1 times 20, 2 times 10, 3 won't go evenly into 20, 4 times 5 will give me a 20, 5 I've already used, so I'm done. I got 3 possible combinations. So look at your middle number, it's a positive 9. So all I want to do is just look to see if I add or subtract, I can get to a 9. If I add, I get 21. If I subtract, I get 19. If I add, I get 12. If I subtract, I get 8. If I add, I get a 9. So it's a 4 and it's a 5. Now, to get a positive 9, since we're adding, they're either both positive or they're both negative. So I'm thinking they both need to be positive to get me a positive 9. And 4 plus 5 is indeed positive 9, so plus 4 plus 5. Okay? I should be starting to sound like a broken record by now. So, if you have not been doing any on your own, this is the time to go do a few on your own and see how you're doing. We're factoring. It's an x squared, an x, and a constant, so I'm thinking binomial times binomial, but check for the GCF first. Are there x's in all three pieces? No, can't pull an x out. Does this one start with a 1? Yes, so the only number that can be pulled out is a 1, so it does me no good. So let's go see if it's factorable. Hopefully it's a binomial times a binomial. What times what will give me x squared? X times x. A number times a number is going to give me the 24 on the ends. Let's make a list. 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5. 5 will not go evenly into 24, and 6 I've already used, so I've got 4 possibilities here. Here's my number that I'm going to decide which pair to choose with. If I add these two, I get a 25. Not my number. If I subtract, I get 23. Nope. If I add, I get 14. If I subtract, I get a 10. Nope. If I add, I get 11. If I subtract, I get a 5. Nope. If I add, I get 10. If I subtract, ooh, there's my 2, so I'm subtracting. So if you're subtracting, that means one needs to be positive, one needs to be negative. If the answer is negative, so I'm thinking the bad guys are going to win, so I should make this one my negative and this one my positive. Before you go on, check it with the calculator. Do positive 4 minus 6 and see if you do indeed get a negative 2. You can also do positive 4 plus a negative 6 if you like to do it that way. Either way, you should get a negative 2. So plus 4 minus 6. Plus 4 minus 6. So those are the two factors that you multiply together to get you that answer. Number 8. Hopefully by now you've worked the rest of them and you're coming back and just checking. Look for GCF first. X, X, no X's. Okay, and here's a 1 here, so the biggest number that can be pulled out is a 1, so no GCF. Hopefully it is factorable into a binomial times a binomial. The first thing has to be an x and an x to get x squared. This number times this number has to equal 15. So let's make a list. 1 times 15, 2. 2 won't go evenly into 15, 3. 3 times 5 is 15, 4. 4 won't go evenly, and 5 I've already used. Excuse me, guys. It's been a while since I've had to talk this much. Okay, so I've got two possibilities. Let's look at the middle number, negative 2. Write it down on your paper so you can see it. If I add these, it needs to be a 2, or if I subtract them. If I add, I get 16. If I subtract, I get 14. Neither of those is a 2. If I add these, I get 8. If I subtract, I get my 2. So I need to subtract these two numbers to get my 2. If you're subtracting, that means one needs to be positive and one needs to be negative. The question is which? Since the answer is negative, I want the bad guys to win. So since I want the bad guys to win, make the bigger number your bad guys. Then check it with the calculator. 3 plus a negative 5, or 3 minus 5. Make sure you get a negative 2. As long as you get a negative 2 as your answer, you're right. Positive 3 minus 5. Now, do you have to put the plus 3 first? No, you could put the plus 3 over here. And you could put the negative 5 over here if you want to. Because order doesn't matter. I could have put this whole parentheses in front, or I could put that whole parentheses. So order doesn't matter in multiplication. 2 times 3 is 6. 3 times 2 is also 6. Order does not matter. All right. Here's another one. Factor this thing. So squared term, x to the... Oh, wait. There's a problem with this one. I need to correct that on my sheet and the thing. They all need to be the same variable, so I forgot to change this one to an m, so just pretend this one's an m. I will change it on y'all's before you get there. Yours will have an m tomorrow. So m squared plus m minus 20. So are there m's in all three pieces? No, so I can't pull an m out. Does the first one start with the 1 as the coefficient? Yes, so 1's the only number that can be pulled out. So that doesn't do me any good. So now let's go see if we can multiply it into a binomial times a binomial. I have an m and an m. Let's see. And then I need two numbers multiplied to give me a 20. So let's make a list. 1 times 20, 2 times 10. 3 will not go evenly into 20, 4 times 5, and 5 I've already used. So these are my three possibilities. What is the number in front of that m? It is a positive 1. So that's the number I'm looking for in the middle, is a positive 1. So if I add these, I get 21. If I subtract, I get 19. If I add these, I get 12. If I subtract, I get an 8. If I add these, I get 9. But if I subtract them, I get a 1. So it's 4 and a 5. So if I'm subtracting, that means one's going to be positive, one's going to be negative. Who needs to win, good guys or bad guys? Good guys. So I'm going to make the bigger number positive and that one's negative. And then check it with the calculator. Negative 4 plus 5 should be a positive 1. So negative 4 plus 5. Here we go. Number 10. Again, we're factoring, and it's a squared term to the first power and then a plain constant. So I'm thinking binomial times binomial. Are there b's in all three pieces? No, no GCF there. Is this starting with a 1? Yes, so the biggest number is a 1, so I can't pull out a GCF. But I always check for GCF first, and that will come in really important tomorrow when we do some with some GCFs. So I have a b times a b to get b squared. And then this number times this number is going to equal my 6. So what are the possibilities? 1 times 6, 2 times 3, And 3 is the next number, and I've already used it. So there's only 2 possibilities, 1 and 6 and 2 and 3. And the middle number is a positive 5. So if I add these, will I get a 5? No, but if I subtract them, do I get a 5? Yes. If I add these, do I get a 5? Yes. So I have both possibilities here, and I have to check them both. So 1 and 6 will work, and 2 and 3 will work. Now, let's think about this. To get to a 5 on 1 and 6, do I need to add them or subtract them to get to a 5? I need to subtract. That means the good guys are winning, so this one needs to be positive, and this one needs to be negative. Now, I'm going to do this twice over here just so I can see both versions and see which one I think is right. Okay, I'm going to do the 1 and the 6 on top. So in order for me to get a positive 5, it's got to be a negative 1 and a positive 6. So negative 1 and a positive 6. Now, since there's 2 versions that are working, I can't just stop there and go on. I got to check this. If you multiply a negative 1 times a positive 6 as that very last final distribution, negative 1 times positive 6, what do you get? Negative 1 times positive 6 gives you a negative 6. Is that my number on the end? No, I have a positive 6. So that will not work. It will give me my middle term, but it will not give me the end term. So always check your signs on that last b times b is still b squared, but negative 1 times positive 6 will not give me a positive 6. So let's check the 2 and the 3. Now to get the 2 and the 3 to 5 is adding. So that means they either both need to be positive or both negative. And since they're both, the answer is positive, I think it should be positive 2 and positive 3. So if I add 2 plus 3, do I get 5? Yes. So let's try the plus 2 and plus 3. Okay. Now, just to double check ourselves, since I had 2 combinations here, because it may be that it's not factorable. Let's just double check it. B times b is b squared. And 2 times 3, does that give you a positive 6? It does. So this one is going to work. And the positive 2 plus positive 3 is going to give me the positive 5 in the middle. So this one does indeed work. So it's not that one. It's the 2 and the 3. So if you get more than one combination that works, just figure out what the signs need to be to get to this, and then check when you multiply them to make sure you still get that number on the end, because it could be a positive 6 or a negative 6. All right, so there's the tricky ones when there's more than one options that will work. So again, we're factoring. A squared, A, and a plain number. Are there A's in all 3 pieces? No, can't pull an A out. Still looking for the GCF. Is this a 1 in front? Yes, so the biggest number that could be pulled out is a 1. So there's no GCF that I want to pull out, so I'm hoping that it's factorable. So this is going to be an A times an A to get me A squared. And this number times this number is going to give me 36. So let's make a list. 1 times 36, 2 times 18, 3 times 12, 4 times 9. Now, if you're not sure about these numbers, you can do 36 divided by 1, 36 divided by 2, and write it down, 36 divided by 3, and write it down, 36 divided by 4, and write that number down. Now, when you get the answer, if it's ever a fraction or a decimal, a messy decimal, then you just cross it off, because we want numbers that are going evenly into 36. 5, 36 divided by 5 will not go evenly, so cross it off. 6 times 6 will give me 36. And then 7, oh, I've already used 6, so I'm 6 now, and then 7. 7 won't go evenly, 8 won't go evenly, and 9 we've already used. So these are my choices. I got a bunch of choices. We're looking for a negative 5. So I write this number down. So if I add them or subtract them, do I get a 5? 37 and 35? Nope. 20 and 16? Nope. 15 or 9? Nope. If I add them, I get 13. If I subtract them, I get a 5. Ooh, that one works. If I add these, I get 12, but if I subtract, I get a 0. So the only one that worked was the 4 and the 9. Now, since I am subtracting to get to the 5, that means one's positive, one's negative. Remember, this was a negative 5. So that means the bad guys should be winning, so I want the bigger number to be negative and the small number to be positive. There's more bad guys, so the bad guys win the battle. 4 of these kill 4 of those. There. Check it with the calculator. 4 plus a negative 9, or 4 minus 9 should be negative 5. So plus 4 minus 9. Now, as a final thing, just because I know today they're all factorable, but I always double check at the very end. I multiply this positive 4 times a negative 9, make sure I do get a negative 36. So just like here we check this piece in the calculator, you should always get in the habit now starting to check this too. 4 times negative 9, make sure you get the negative 36. Because occasionally, in future ones, there will be not factorable. And that's the thing that's going to kick it out, is when you try to do this multiplication on the end, it does not give you that answer. The number will work, but the sign won't work. So always kind of check that at the end now too. And I will remind you of that at the beginning of the lesson tomorrow. Okay, number 12. R's in all 3 pieces? Nope, no R to pull out. Is there a 1 in front of this one? So the biggest number that I can pull out is a 1, so no GCF today, but hopefully it's a factorable. R times R is going to give me R squared. What times what is 20? Let's make a list. 1 times 20, 2 times 10, 3 won't go evenly, 4 times 5, 6 won't go evenly, 7 won't go evenly, 8 won't go evenly, 9 won't go evenly, and 10 we've already used. Okay, so there we go. Oh, I skipped 5. I guess if I'd gone, I could have stopped right here at 5 instead of we've already used 5. So we got 3 possibilities there. The middle number is a negative 12. So if I add or subtract, do I get a 12? If I add, I get 21. If I subtract, I get 19. If I add, I get a 12, okay? If I add here, I get a 9. If I subtract, I get a 1. So it's 2 and 10. Now, I'm adding these two numbers to get to the 12. So since I'm adding, that means they're either both positive or they're both negative. If I make them both positive, I get a positive 12. And I don't want positive 12. So if I make them both negative, negative 2 plus a negative 10 does indeed give me a negative 12. So negative 2 minus 10. And then just to check this final piece up here, if I do negative 2 times negative 10, I do get a positive 20. So that sign does work. All right. Last one is your exit ticket. I'm going to let y'all go do that one. It's multiple choice. So you could literally multiply all these out with a double distribution to see which one works, or you could go factor it over here and do it that way. Or you could just check the first piece. M times m gives you m squared. They're all m times m's. And then I have a 30. So 15 times 2 is 30, 10 times 3 is 30, 15 times 2 is 30, and 10 times 3 is 30. So they didn't, none of them were knocked out on just the easy stuff, but you can go ahead and either factor it by hand or just do the double distribution and see which one works. That's your exit ticket. Bye, guys.